Hello students, how are you all? I hope you are doing absolutely fine. So welcome all of you at AriserTalent, and I am your chemistry teacher Krina, and we had started our chapter, that is the class 9 chapter of the chemistry, that is matter in our surrounding. So let's discuss which topics we have dealt until now. So until now we have gone through the introductory part of the matter in its surrounding. So firstly we have discussed about definition and general introduction of matter in our surrounding. Secondly, we have discussed about the characteristics of the matter with the experimental proofs. We have discussed about the characteristics of the matter, and we have seen some experiments regarding these characteristics of the matter. Now, in this characteristics of the matter, we have discussed the two terms, that is diffusion and the Brownian movement of the particles that usually occur in the gaseous form. So, we have gone through a next topic, that is about diffusion and Brownian movement. Then we have discussed about the states of the matter, that is solid, liquid and gas, and we have an introduction about the two new states of the matter, that is plasma and BEC. So we have discussed about the 5 states of matter. We have a discussion about 5 states of matter including plasma and BEC. Then we have discussion about the interconversions of the states of the matter, that was our previous lecture. It means conversion from solid to liquid, liquid to gas, and the solid to gas conversion. So our next topic was interconversion of states of matter. Then in interconversion of the states of the matter, we have a curve that is known as the temperature time graph we have discussed. So the curve we have discussed is about the temperature time graph. In the process of interconversion of the matter, we have also introduced a new term, that is about the latent heat. So we have also discussed about the latent heat. Now we have seen that interconversion of the matter basically occurs at the two conditions. So we have discussed that interconversion will take place when you change the temperature or when you apply the pressure. So interconversion is possible only when you change the temperature. It means either you may decrease or increase the temperature, or either you may apply the pressure. So these are the conditions for the interconversion of the matter we have. So these are the topics that we have covered in our first chapter, that is matter in our surroundings. So interconversion of the matter in terms of the temperature we have discussed now. Now we are moving to our next topic, that what will happen if you are going to apply pressure on the states of the matter. So we are left with this topic, and the last topic of this chapter is about the evaporation, which is a very important topic, and we will end this chapter from evaporation now. So the last topic is all about evaporation and its application. So this will be our last topic that we will discuss in this chapter. Until now, whatever we have discussed, you have analyzed that this topic belongs to our day-to-day life activities, and what we see in our environment basically belongs to this chapter only. So the topics we have covered now until is up to the latent heat, and we are left with evaporation. But before that, in interconversion of the states of the matter, we have to discuss one more term, that is about the pressure. Now what will happen if we apply the pressure on the states of the matter? Suppose what will happen here, suppose you are applying a pressure to something, either its particles will be come close together. So the pressure we can apply in gases only. In solids and liquids we do not apply any pressure because the intermolecular separation is not so large as compared to the gases. In the gases the particles are distributed far away from each other. It means intermolecular distances between these particles is very large. So when you apply the pressure, these particles will come close together and they will change the state of a matter. So how the effect of the pressure occur, let's discuss here. So our next topic is about effect of pressure. Now, when you apply the pressure, the particles will come close together and this will occur only in the cases of the gases only. So, let us assume that we had given two systems here. Now, look at both these structure. What you can analyze here, we have taken a particles that are of the gaseous form in a container. So I can say that these particles are of gases. So these are gaseous particles. Now you can see there is a very large intermolecular separation between the particles. It means intermolecular distances are very large. When we apply a piston to this cylinder, when I am applying piston to this container, what we can see that this is a piston we have. Now when you apply a piston to this container, you can see that the gaseous particles, this is our system 1 and this is our system 2. In system 2, the gaseous particles will come close to each other. It means the compression of a gases will take place when you apply a pressure through the pistons. In this diagram, you can see that the intermolecular distances are very large, and when you apply the pressure to the gaseous particles, they will come together and the distance between the particles will get reduced. Now, this is the basic diagrammatic representation that will happen when you apply the pressure on a gaseous particles. Let us consider the one application of applying the pressure in our day-to-day life. You have heard about the term carbon dioxide. Carbon dioxide is usually found in the gaseous state in the atmosphere. But now what will happen when you apply a pressure to the carbon dioxide, it means if you apply the pressure 70 to 80 times greater than the atmospheric pressure, the carbon dioxide will convert it into the liquid, it will convert it into the solid form, that is known as the dry ice. Have you heard the term dry ice? Dry ice is actually a ice that we are using in coolant refrigerators, and to keep the ice creams cold in any environment where the temperature is very high, we usually use the dry ice. So dry ice is a basic thing that is called the solid CO2 we are using in our day-to-day life. But what will actually happens there, the carbon dioxide we have in the gaseous form, the solid CO2 is in the solid form, but gas is converted into solid on applying pressure, but it will not attain an intermediate state, that is liquid state. It means जब कार्बन डाइऑक्साइड को हम कंप्रेस करके सॉलिड CO2 ड्राई आइस का फॉर्मेशन करेंगे तो हमें कोई लिक्विड स्टेट अचीव नहीं होगी. It means we will not get any intermediate state of liquid there. This is a direct conversion from gases to solid here. So this is all about the dry ice where the application of the pressure is basically applied. So what will happen here? Suppose we have carbon dioxide. Now this CO2 that is available to us is in gaseous form. This CO2 is available in the gaseous form. Now what we are doing, we are applying the pressure that is 70 to 80 times greater than the atmospheric pressure. On this gaseous form, if we are going to apply the pressure, if we are applying pressure here, this gaseous carbon dioxide will convert into solid CO2. This will convert into solid CO2, and solid CO2 is nothing but it is called dry ice. It is known as dry ice, and this is a conversion directly from liquid to the gaseous to the solid form. It means there is no intermediate step obtaining here, and the liquid form of the matter will not be achieved here. So this is a direct conversion from gas to solid, and this CO2 has found its application in cool refrigerants and to cool ice creams. Now where its application have been found there, you have seen that the ice creams kept at any shops, we have bought any ice cream from any ice cream parlor, you can see that in that ice cream parlors the ice cream will not get melt easily. This will not get melt easily just because of this solid CO2, because they are using solid CO2 as a refrigerant or as a cooling agent to keep that ice creams cool. So this is the application of solid CO2 in our day-to-day life. Now you have seen that when applying pressures you can convert any state of a matter into the another form, but generally it is used for the gaseous form because the intermolecular separation between the particle of gases is very, very large. Now let's discuss here about the unit of pressure. So here we are discussing about unit of pressure. Now every physical quantity has some sort of unit to describe it. So the unit for the pressure we have is Pascal. So pressure is always calculated in Pascal, and we can also write after pressure that is called ATM. ATM means atmospheric pressure. Now 1 Pascal will be equal to 1.1 into 10 raised to the power 5 atmosphere. So these are our two units, that is Pascal and atmosphere, for defining the pressure. Pascal is the SI unit for pressure. This is the SI unit of pressure, and when you want to calculate the pressure exerted by the gases, you usually write ATM here, and 1 ATM will be equal to 1.1 into 10 raised to the power 5 Pascal. This is the conversion formula. So this is the unit of Pascal, and Pascal is our SI unit of system in case of the pressure. So we have discussed about the interconversion of the states of the matter by applying pressure. So earlier we have discussed about the changes in the temperature, and here we have discussed about the changes in the pressure. So you can analyze that the temperature and pressure are the very essential quantities for changing one state to another. Now let us move to the next term we have in this sequence, that is a very new term, and this term is known as specific heat. Now what is specific heat? Let's discuss now, but before that you can copy it from here. So let's start our new definition, that is about specific heat. Now what is specific heat? So specific heat of a substance is the amount of energy or amount of heat required to raise the temperature of one unit of a substance. It means जो amount of heat is a form of energy we have, तो जितने amount of energy हमको needed होगी किसी 1 किलोग्राम सब्सटेंस का टेम्परेचर रेस करने के लिए, उसे हम बोलेंगे हमारी specific heat. It means this term is specific for every quantity present in the nature. So let us write the definition here. It is the amount of heat required to raise the temperature of a substance by 1 degree Celsius. It means we have to raise the temperature of any substance by 1 degree Celsius. We have to apply the specific heat to that substance. Now you can see that heat is a form of energy and the unit for the energy is joule. So I can write here, it is the amount of heat, and heat is what? Heat is a form of energy we have, and the unit for energy will be joule. And we are raising the temperature of a substance. So the substance is always counted in a kg or gram. So I am considering here the standard unit. So for the unit of mass we have kg, and you know that we are raising the temperature by 1 degree Celsius. So the temperature of the substance will be in degree Celsius. So these are the three units we are getting from here. So we can conclude the another definition for the specific heat of a substance. The specific heat of a substance in joules is the amount of energy required to raise the temperature of 1 kg of a substance by 1 degree Celsius. It means amount of energy we are required in joules. So I can write one more definition here. It is the amount of energy in joules. required to raise the temperature of 1 kg of substance by 1 degree Celsius. So, this is the another definition we can conclude from here about the specific heat. Now, specific heat is represented by a symbol C. For the specific heat we will use the symbol C, but sometimes also we will use the symbol S. So, sometimes we also use the symbol S for defining the specific heat of a substance. Now, specific heat of a substance की unit क्या होगी? So, the unit of specific heat will be, now you can conclude the unit from here. It is joule, it is kg and it is Celsius. So, the unit of specific heat of a substance will be joule per kg degree Celsius. So, it is the amount of heat energy required to raise the temperature of 1 kg of a substance by 1 degree Celsius. So, this type of specific heat is basically used when you have a interconversion of the states of the matter. Now, this is the specific heat we have discussed here. Now, we are moving to the last topic of the chapter, that is about the evaporation and its cooling effect or its application in our day-to-day life. So, let us begin our new topic, that is about evaporation.